Hello everyone, welcome to Math Tired Club, where we make all those hard things in math very, very easy. I hope you're doing well. Don't forget to like, subscribe, and comment, and also share the videos with your friends if you find them helpful. I want to thank you for your comments and support. It really gives me a lot of enthusiasm to make better videos every day. Okay, today we're going to talk about rationalizing radicals. Okay, I'm going to try to explain it as simple as possible. I totally recommend you to watch the previous video, which I explained simplifying radicals in in the easiest way ever, honestly. And today we're going to talk about rationalizing radicals. So the very first thing is that, okay, give me 1 second. I'll be back with the examples. Okay, ta-da, I'm back with my examples. Okay, the very first thing that you need to do in order to see if you need rationalizing or anything else is to simplify radicals and write them in the simplest form possible. So the first thing is that I will simplify this x2 and this x4, and it's going to be x2 on the top, and then y and y cubed, and it's going to be y squared in the bottom. So I'm going to have 5x squared on the top, and then I'm going to have 2y squared on the bottom. So over here, this has the money. If you watch the previous session's video, you will get this very, very easily. Pays and comes out. This one again pays and comes out. The thing with rationalizing is that we can never end up with a radical in the denominator. And if we do, we need to remove it. So I'm going to tell you something. We can always multiply numbers by 1. Am I right? Because 1 is not going to change anything, right? If I multiply something by 1, it's not going to change anything. So I can always do that. Is that correct? So what if I changed 1 to another format so that I can get rid of the radical in the denominator? So do I care about the radical in the numerator? No, I don't. And do I care about the numbers out of the radical in the denominator? No, I don't. I just care about this 2 that is under the radical. 2 is to the power of 1. How much more 2's does it need in order to be able to pay and come out? 1 more, is that right? So that if it's going to be 2 to the power of 2, then it can pay and come out of the radical. So I will multiply it by radical 2 over radical 2, which is technically 1. So the things on the numerator they're going to get multiplied by each other, and the things on the denominator are going to get multiplied by each other. As you can see, now this 2 has the money to pay and come out, so it's going to be x radical 10 over 2y, and that's the most simplified form, and you just got rid of the radical and you're good. And this is the simplest form of this radical, all rationalized and all fine. So look at this one now. I'm going to do the same thing. And I forgot the index is 3 here. Do I care about what the index is? No, I'm going to do the same thing. It's just the currency of the money that is going to change. Don't forget that. The powers are supposed to be something divisible by 3. That's the only thing that changes. So the a and a cubed is going to be a squared. B and b cubed is going to be b squared. C and c squared is going to be c to the power of 1. This by 2, 6, and this by 2, 5. So I'm going to rewrite it. It's going to be radical 6 b squared c over radical 5 a squared, and that's it. Okay, so first of all, I'm going to check if any of the numbers can pay and can come out. This is 6 to the power of 1. It doesn't have anything, so it will remain. B squared, we need 3. It can't pay. C1, it can't. This one as well. Okay, so I need to get rid of the radical in the denominator. So the index is 3. I have 1, 5. How many more 5s do I need for this to be able to pay and come out? 2 more. Is that right? And I have a to the power of 2. How many more a's do I need? 1 more. So it's going to be the same thing over the same thing, so that it's like I'm multiplying stuff by 1. Then the numerator is going to get multiplied by the numerator. So it's going to be 6 times 5 to the power of 2. A, let me write times like this. B squared and C. And in the bottom, I'm going to have 5 to the power of 3 and a to the power of 3. This space comes out, this space comes out, and that's what I wanted in the first place. So 5a over. So over here, I can't simplify anything. Nothing can pay and can come out of the radical. So it is going to be the same thing. So it's going to be 150 a, b squared, and c with the index of 3. And none of these can pay and can come out of the radical because at least they need 3, okay? So that was one part of rationalizing. The other part is when there is something that is getting added and subtracted. So I'm going to be back with those examples. Okay, ta-da, I'm back with my examples. So guys, what if I have something like this? Look, the very first thing that you would do in these type of question, again, is simplifying as much as you can. This is going to be 9 times 3, and 9 is 3 to the power of 2 times 3. So this is going to be radical 3 to the power of 2 times 3, which this is going to pay and come out. So it's going to be 3 radical 3 minus radical 2, because that can't get any simpler. So can I add or subtract these? No, because they're not like radicals, right? But what am I supposed to do to get rid of the radicals in the denominator? What is the thing that would separately raise both of these numbers to the power of 2 without doing anything like odd or anything wrong? So I want you to remember this special case, guys. The difference of square. So a squared minus b squared. So this is the only special case which I can use in order to separately raise these both to the power of 2. So I already have the a minus b part. So if I multiply it by its conjugate, meaning the opposite, I can have 3 radical 3 plus radical 2. I can have the other part as well. 3 radical 3 plus radical 2, because I can only multiply stuff by 1. So it has to be the same thing over the same thing. So this is going to be 4 radical 3 radical 3 plus radical 2. And in the denominator, I'm going to have 3 radical 3 minus radical 2 and 3 radical 3 plus radical 2. Guys, as you see, I just created the special cases here. A minus b, this is the a and this is the b, times a plus b, which the answer is a2 minus b2, right? So this is going to be, what's the a? 3 radical 3 to the power of 2. And what's the b? It's radical 2 to the power of 2. And on the top, I'm just going to rewrite what I had before. So over here, guys, this power is for this and this at the same time. So it's going to be like, it's like this, 3 to the power of 2, radical 2 to the power of 2, okay? Which is going to be 9 radical 2 to the power of 2 that is going to pay and come out. So it's going to be 9 times 2, which is going to be 18, okay? So that is going to be 18. And radical 2 to the power of 2 is just going to be radical 4, which is 2. So it's going to be minus 2. And then I will just rewrite what I had on the top. Let's do something. Since I don't have enough space here, I'm just going to put this. So 18 minus 2 is going to be 16. 4 times 3 radical 3 plus radical 2. And then you simplify the 4 and the 16. This is going to be 4. So it's going to be 3 radical 3 plus radical 2 over 4. As you can see, I just removed the radical very easily and I just continued, okay? So look at this other example of mine. It's radical 11 plus 3. So the very first thing is this, that I'm going to check if there is anything that can get simplified and come out. This is 4 times 11, and 4 is 2 to the power of 2, right? This is going to be 4 times, 11. And 4 is 2 to the power of 2. So I'm going to write it as 2 to the power of 2 times 11 times x to the power of 2. Guys, so 2 to the power of 2 times 11 times x2. Okay. Over radical 11 plus 3, okay? So this is going to pay and come out. So it's going to be this will pay and come out, and this will pay and come out. So it's going to be 2x radical 11 over radical 11 plus 3. As you can see, you're going to end up with a radical in the denominator. So what you're going to do is that you have to get rid of it by making the special case. So I'm going to multiply it by 1, but I'm going to make one in a form that I will have the special case. Look, I have the a plus b part here. I need the a minus b part. So it's going to be radical 11 minus 3. And it's going to be the same thing over the same thing because I can just multiply stuff by 1. So it's 2x radical 11 times radical 11 minus 3, radical 11 to the power of 2 minus 3 to the power of 2, okay? So radical 11 to the power of 2 is just going to be like this. It's going to pay and come out, so it's going to be 11. 3 to the power of 2 is going to be 9. And then this one, 2x times radical 11. Guys, I'm just going to write it over here. 2x radical 11 times radical 11. It's going to be 2x radical 11 to the power of 2. This is going to pay and come out, and it's going to get multiplied by the 2. So it's going to be 11 times 2 times x, which is 22x, right? And then minus 6x radical 11. So 11 minus 9 is going to be 2. Oh, okay. You can just write it like this. Or you can do something else too. You can continue this one step further. You can factor out the 2 here, and it's going to be 11x minus 3x radical 11. And you can just simplify these two. And your very last answer is going to be 11x minus 3x radical 11. And that's going to be your last answer, guys. Okay? So I hope that you have understood this lesson. Guys, don't forget to like and subscribe. Have a great day. Bye.